Have you ever really thought about what's going on inside your computer? Really thought about it? Well, today we're going to pull back the curtain and take a look at its brain. We're going to unlock the secrets that make all your favorite apps and games actually work.
Seriously, think about it for a second. You tap an icon on your phone to launch a game. How does that tap become a game? There's this secret conversation happening, really fast, between the app and the computer hardware. And we are about to listen in.
So the secret middleman in this whole conversation is something called the operating system, or just the OS. It's kind of like a translator and a traffic cop all rolled into one, handling everything between your software and the physical computer. For a lot of people, it just feels like this mysterious black box, but today, we're going to peek inside.
All right, so the first clue in solving this mystery is figuring out how all these different parts even talk to each other. The app and the computer's processor don't speak the same language, so how does anything get done?
Well, they use something called an API. It stands for Application Programming Interface. But honestly, the easiest way to think about it is like a universal translator from Star Trek. If your app is speaking Spanish and the computer hardware only understands Klingon, the API is that brilliant interpreter in the middle, making sure every single command is understood perfectly.
Now, one of the most famous and important of these translators is a standard called POSIX. This one's a big deal. It's been around for a long time, and it's become this almost universal language for tons of different computers.
So why should you care about something like POSIX? Well, imagine you're a programmer before it existed. It was tough. You'd have to write your app's code, then completely rewrite it for a Mac, then rewrite it again for a Linux computer, and on and on. It was a nightmare. But with POSIX, you write your code one time, just once, and that single piece of code can run on all these different systems. It's a total game changer.
But here's where our story gets a little tricky. These simple, easy tools, these universal translators, well, they're not always perfect. And this is where things get really, really interesting if you want to be a programmer.
There's this famous saying in the programming world, all abstractions leak. Now, abstraction is just a fancy word for a simple tool that hides a bunch of complicated stuff. And leaking? That just means that sometimes that simple tool can't handle a special situation, and all that hidden complexity kind of leaks out.
Let me give you a perfect example. A universal remote control. It's a great abstraction, right? You pick it up, it turns the TV on, it changes the volume, it does the basics for pretty much any TV. But what happens when you want to open up that special Netflix menu? Uh-oh, the universal remote doesn't have the right button. You have to go dig through a drawer to find the original remote that came with the TV. That's a leak. The simple tool wasn't enough, and you had to understand the specific details to get the job done.
And on top of that, there's another challenge. Technology is always moving forward. And sometimes the changes are so huge, they create a clean break from the past. A great example is the jump from 32-bit to 64-bit computers.
It's just like video games. You can't play the latest, most amazing new game on a console from 20 years ago, right? The old machine just doesn't have the horsepower. To unlock those awesome new graphics and features, you just have to move on and leave the old tech behind.
All this brings up a really interesting question. If the OS is just the middleman, could you just get rid of it? Could you actually build an app without using an operating system at all?
And the answer is, yeah, technically you can, but you probably wouldn't want to. It would be incredibly hard. See, the OS gives you all these essential tools and building blocks for free. Building an app without it would be like saying, I'm going to build a house, but first I have to go out and make my own bricks and forge my own hammer and chop down trees for wood. It's just so much easier to use the tools that are already there for you.
Okay, so let's check out a real-world story that shows how understanding these hidden details is basically a programmer's superpower. This one comes from TikTok's parent company, ByteDance. So here was the problem they were facing. They had this monster computer with 120 hard drives packed inside, but every time they needed to shut it down, it was taking forever. Just way too long.
And here's why. The operating system was telling each of those 120 drives to shut down one by one. It was basically like having to call 120 friends to say goodbye. But you have to call the first friend, wait for them to say bye and hang up, then you can call the second friend, wait for them to hang up, and you have to do that 120 times.
And how long did this take? Get this, up to 36 seconds, which might not sound like a lot, but in the world of computers, that's an eternity.
But then, an engineer who really understood what the OS was doing under the hood had this brilliant idea. They thought, wait a minute, what if instead of calling each friend one by one, we just send one giant group text?
What if we tell all 120 drives to shut down at the exact same moment? The result was absolutely staggering. The shutdown time went from 36 seconds all the way down to just 0.3 seconds. A massive, massive improvement, all because one person dared to look inside that black box and find a smarter way.
And that story, right there, is the perfect example of what I call programming with X-ray vision. When you actually understand what the OS is doing deep down, you can see problems and find solutions that no one else can.
This is exactly why these details matter so much. This knowledge makes you a fundamentally better programmer. You start to get it. You realize that switching between apps isn't free. It actually costs the computer time and energy. You know that grabbing a piece of information from memory isn't instant. And once you know these secrets, you just naturally start writing code that's faster, smarter, and way more efficient. So, this brings us to our final mission today. We are going to completely demystify this idea of the OS being some kind of magical, untouchable thing. It's time to look right inside that black box.
Because here is the final secret, the big reveal. From the outside, the operating system can absolutely seem like magic, but when you finally peek inside and look at how it's built, you realize it's not magic at all. It's just code. It's made of lists and tables and simple logic, the exact same building blocks you use when you're learning to program. It's complicated, for sure, but it's not magic, and you can understand it.
And that's really what I want to leave you with. The moment you stop seeing the OS as a black box that you're not allowed to touch and start seeing it as a transparent box that you can understand, everything changes. You'll start asking better questions, you'll build much better apps, and who knows, maybe someday you'll be the one who finds that brilliant, simple fix that nobody else saw coming. So stay curious, keep learning, and start asking yourself, what will you build or what will you improve?